Section 6.6. Function operations. So the first part of this assignment is the hardest part. I'm going to tell you that up front, okay? When we talk about operations, that means that we're going to take two different functions, we're going to add, subtract, multiply, and divide them. However, the hardest part of this lesson is finding the domain. So that's where I want to start. Okay? Domain. Now remember that domain is your x values. We've talked about domain before, right? When you are finding the domain, there are two things you look for. Question 1, is there an x in the denominator? And question number 2, is there an x in a square root? If it is no to both of those, the domain is negative infinity to positive infinity. If yes to denominator, set denominator equal to 0 and solve. This is where x cannot exist. Okay, so for example, before I get to number 2, what? What? Go ahead, Jordan. Yes, it does. It matters to me very much. What was it you were asking me? If the denominator, if it's yes to the denominator, question number 1, then we're going to set the denominator equal to 0 and solve it. I was just going to show you, okay? All right, so let's say I have f of x equals 3 over x minus 4. There is an x in the denominator, right? So I would take my denominator, set it equal to 0, and solve it. I get x equals 4. That is the one place in my domain that the x cannot exist. So my domain would be negative infinity to 4, a u, 4 to infinity. All right, does that make more sense now? Okay. If yes to the square root, then set inside greater than or equal to 0 and solve. This is the domain. So what I mean by that one is that if I get f of x equals the square root of 2x plus 6, there is an x inside a square root. So I take what's inside the square root, set it greater than or equal to 0, because you can't have something less than 0 inside a square root, right? So then I solve it. I have 2x is greater than or equal to negative 6. Divide both sides by 2. So x is greater than or equal to negative 3. So in this case, my domain would be, whoops, bracket, negative 3 to infinity. All right, so that being said, example number 1, you guys are ready? All right, here we go. Example number 1. This is for 10 through 20. Perform the indicated operation and state the domain. Let's say f of x equals 2x plus 1 and g of x equals x minus 4. First operation we're going to do is I want to do f divided by g. So I literally take my f function and put it over my g function. Then I say, is there an x in the denominator? I take my denominator, since I said yes, I take my denominator, set it equal to 0, and solve. So I get x equals 4. So for my domain, it is negative infinity to 4, 4 to infinity. Okay? I'm going to save those two. Let's do another one. That's it. Okay, what if I had f times g? So I'm going to take f, which is 2x plus 1, and times it by g, x minus 4. Do I have an x in the denominator? There is no denominator, right? Do I have an x inside a square root? So then my domain is? Perfect. Okay. Let's do one more real quick. Same section. What if I had f minus g? So my f is 2x plus 1 minus my g, which is x minus 4. If I'm minusing that one, I have to distribute my negative, right? So I have 2x plus 1 minus x plus 4, and then I collect like terms, so I get x plus 5. Is there an x in the denominator? Is there an x inside a square root? So then my domain is negative infinity to infinity. Oh, actually, that went all the way through 26. Same thing all the way through 26. That's what you're doing. Now, next section. Next section. In the next section, we have what we call I call it FOG. It's actually a function of a function. It's a composite function is what it's called. Composite function. We say this f of g, or it can also be written as f of g of x. These mean the exact same thing. So now the way these work is you're going to be where this x is, you're going to be given a number. You take that number and you plug it into the g, get out a number. You take that number and plug it into the f. So, let me show you. If I have f of x equals 2x minus 1 and g of x equals 3x squared, and we have f of g of 2. I start by taking 2 and plugging it into the g equation. So I plug 2 into my g equation, so I have 3 times 2 squared. Or I get 12, right? So I have 12 right now. I now take that 12 and plug it into my f equation. So I have 2 times 12 minus 1. Correct. Okay, that's how function notation or composite functions work. So we're going to try a couple of them. So this is actually example number 2. And this is what we are doing for the rest of it, 28 through 44. So I'm going to tell you f of x equals 2x squared. Let's go with g of x equals 3x minus 5. Move this up so everybody can see. We're going to start with doing f of g of 3. So we're going to start by taking our 3 and plugging it into the g equation. So right here I have 3 times 3 minus 5. 3 times 3 is 9, minus 5 is 4. So I have 4 right now. I take that 4 and plug it into the f equation. 4 squared is 16 times 2 is 32. That's my final answer. So before I keep going, give me a question. Okay? Let's do g of f of 3. So this time we're going to take 3 and put it into f first. So I have 2 times 3 squared, which is 18, right? I take that 18 and plug it into g. 3 times 18 minus 5. So what, 54 minus 5? Is it? Yeah. Okay. No, he's right. I'm not done. What are you guys doing? It's all right. We still have a few more minutes. It's only 2:02. All right, let's do f of x. So f of 5. So we're going to take 5 and plug it into f. So it goes right here. So we have 2 times 5 squared. 50, good. So now I'm going to take that 50 and plug it back into f. So 2 times 50 squared. Isn't that 5,000? 50 times 50? Okay. Just making sure. All right. So do we have any questions how this works? Okay. Well, hold on. So what are you lost about? Okay. It goes like backward. You'll start from the end and you always go this direction. Gentlemen, is there something I need to explain further? Okay.